This video explains how to find molar mass. We're going to start by balancing this equation. There we go. So we're going to count. We have 1 silver, we have 1 nitrogen, 3 oxygen, 2 hydrogen, 1 sulfur. This side we have 2, 1, 1, 1, and 3. I'm going to start by balancing the silver. I'm going to multiply this formula by 2 and recount. 2, 2, 6. Now my silver and my sulfur are balanced. The rest aren't. So I'm going to start with the next step will be nitrogen. I'm going to multiply this formula that has the nitrogen in it by 2 and recount. It's 2, 2, and 2 times 3 is 6. Now they're balanced. So we also know there's a 1 here and a 1 here. What do these numbers stand for? Well, they stand for moles. We know that a mole equals 6.02 times 10 to the 23rd particles. And in this equation, it tells me if I want to make these two compounds, I need to start with 2 moles of silver nitrate and add 1 mole of hydrosulfuric acid, and that's going to produce 1 mole of silver sulfide and 2 moles of nitric acid. So this equation tells me what to do in the lab here to produce this. Well, if that's a mole and it equals particles, how in the world do I ever use that? Because I can't measure particles in the lab. I can't measure atoms in the lab or molecules or formula units. Well, I need to use what we call molar mass. Molar mass is the mass of 1 mole of any substance. In chemistry, that is usually molecules and compounds. So let's find the molar mass of sodium chloride. The first one we do is write our elements and count how many. Then, using the periodic table, we find out what the atomic mass unit is of sodium. And it happens to be 22.9. So we round it up to 1 decimal place, 23.0. Chlorine rounds up to 35.5. And that point is important. Then we add these two together. So what we're doing is adding the mass of the number of nitrogens plus the mass of the number of chlorines to give the mass of the total compound. And we call this 58.5 grams per mole. 1 mole of sodium chloride would weigh that much on a balance. So let's go on to some problems. We already did sodium chloride, so let's go on and do water. Water has 2 hydrogen and 1 oxygen. From the periodic table, I find out that the mass of hydrogen is 1 and the mass of oxygen is 16. We have 2 hydrogens, so now we have to multiply 2 times 1, that's 2. And we only have 1 oxygen, so that's 16. Add them together. 16 plus 2 is 18 grams per mole. So if I wanted to get 1 mole of oxygen in a balance, I would weigh out 18 grams of it. Let's try a little more complex one. H2SO4, sulfuric acid. I've already got this written. We have 2 hydrogen, 1 sulfur, 4 oxygen. Looking at the periodic table, hydrogen has a mass of 1. Sulfur has a mass of 32.06, and I round that up to 32.1. Oxygen has a mass of 15.99, so I round that up to 16. Now I multiply across, so we have 2, 32.1, and yes, you have to leave that 1 there. We do it to 1 decimal place, and 4 times 16 is 64. Add them all together. 4, 5, 6, 7, 8. 98.1 grams per mole. So if I want 1 mole of hydrogen, sulfuric acid, that's how much I would weigh out. Let's try one of the formulas from our equation. Silver nitrate. We have 1 silver, 1 nitrogen, and we have 3 oxygen. Silver's mass is 107.9. Nitrogen is 14.0. Oxygen is 16. 3 times 16 is 48. Add them all together. Oh, made a mistake there. No, I didn't. I end up with 169.9 grams per mole. Now, I want you to try H2O2, and then I will put it. So you should have gotten 34.0 grams per mole. All right. So how do I use this in a lab? Let's say I want 0.2 moles of NaCl. First thing I have to do is figure out the molar mass. And then I use our conversion factors. We have 58.5 grams per mole, but I don't want a whole mole, I want 0.2 moles. Moles cross out, multiply this times this, and that gives me grams. And then I weigh out that many grams. And I do that for all of the formulas that I make in the lab.